we look at the sky at night, we cannot separate space from the light that illuminates it. We see the stars because they would shine on their own, not because space would illuminate them. When it is said that a black hole would bend the space around it, deflecting the light that passed in its vicinity, this information would be given to us indirectly by the deflected light and not by space. Science uses this fusion between the behavior of light and space when it assumes that light would be formed by continuous waves. The applications that derive from the false continuity of electromagnetic waves are countless and very well known. For example, if light waves were continuous, we could measure the distances that separate us from the stars, as well as time. Doppler would also be dependent on this continuity of electromagnetic waves while they deviate towards blue or towards red. The effect, therefore, would depend on the polarization of the waves. The justification for this apparent fusion between the behavior of space and that of light would be found at the subatomic level of matter and not at the astronomical scale. It is possible that at some point, light and space would merge into one thing. But, if they remained so, we would not be able to know of their existence. Our memory would be structured over time. In the case of the polarization of light, time would be forcibly excluded in the process of fusion between light and space. At the beginning of the 20th century, physics realized that, in order to be registered by our measuring equipment, light would need to be packed or quantized. It was the awakening of quantum mechanics. Before quantum mechanics, it was thought that a free electron, when colliding with a metal plate, would suck energy from the plate until it accumulated enough to make its quantum leap. This should involve some time lapse. However, it was proven that there is no time gap separating the scattered light from the electron hit by the quantum. Both appear simultaneously. That is, quantization would be a timeless process. Taking time out of this equation, quantum spreading would appear to be continuous, as it would be the only part of the process that would allow direct access. The illuminated electron is, therefore, always seen with a delay. You could not detect any interruption in the flow of light scattered by an illuminated electron, which suggests that the arrow of time would have reversed forever at the very moment of light scattering. Another important detail is that the wavelength of the scattered light is always greater than that of the incident light, according to the theory of the photoelectric effect. Therefore, this stretching of the light and its redshift would be, forcibly, related to the timeless quantization of the light, which is used to illuminate the particle. That is, the causes of the redshift would be prior to quantum scattering, which would prevent the particle from being seen in real time. In the relationship between space and light, quantization suggests that, as light current is forming a packet of condensed energy, space would be negatively stretched. We say negatively because the force would point in the opposite direction to its stretching. We can understand then why science has attributed the contraction of time to the stretching of space at the atomic level and not to the packing of light. According to the theory of relativity, as space stretched, it should contract time due to the complementarity between both. The more you penetrated to the subatomic level, the more time would tend to zero. This tendency would need to be suspended to infinity, aiming to preserve the uncertainty principle. If light were to retain time during its packaging, it would promote an unrecordable break in the space-time continuum. This is due to the finding that, if it weren't for light, we wouldn't have another tool to measure time at that microscopic level. This disruption of the space-time continuum would have important consequences on the macrostructure, at least when it comes to the observation of distant events. The viewer can see the subtle detail that, if the quantum system operator depends on the delayed scattering of light photons to register the presence of an electron, he also depends on the local scattering of light to see the brightness of a distant star. This explains why there is no time in our future, which is where starlight would have to have passed before reaching us on Earth. In the case of the electron, this future appears to be contained between the two subsequent energy levels, where the particle cannot be found. The future would be a kind of illusion, as a result of you only being able to look backwards into the present of electrons and stars. Thus, what is happening on the astronomical scale at this moment would be as timeless as what is happening at this very moment on the subatomic level.